Okay, problems 13 and 14. I'm guessing that we're going to jump a little bit in level of difficulty here. 13, we got air traffic control. An airplane is flying at an altitude of 7 miles. So we got this airplane going this way, and its altitude is 7 miles. Directly going to fly over a radar antenna, as shown in the figure, when the plane is 10 miles from the antenna. So here's the antenna right here. When the plane is 10, when the plane is 10 miles from the antenna, which would be this distance right here, right? So that's going to be 10. I'll use the same variables they used. They used x and s here. The radar detects the distance is changing at a rate of 300 miles per hour. That's ds dt is 300 when the plane is 10 miles. So when s equals 10. So the question is, find the speed of the airplane. So we need a variable that relates x, 7, and s. Pythagorean theorem would work, of course. Sometimes we use angles in these problems, actually, which we'd use some trig functions, but we just use the Pythagorean theorem here, which will be 7 squared plus x squared equals s squared. So now take the derivative. The derivative of 7 squared is 0. That 7's not changing. So we got 2x dx dt equals 2s ds dt. And the question is, find the speed of the plane, which is dx dt, right? X is that plane's movement. So when s is 10, so we need to do a little math here. So notice, here's my little right triangle. This is 7, that's 10. So this would be the square root of 100 minus 49, which would be the square root of 51 for x. So we're going to go, I'm going to cancel those 2's if that's all right with everyone. X is root 51 times dx dt, which is what I'm looking for, equals s, which is 10, times ds dt, which is 300. Do a little math here. We get 3,000 divided by the square root of 51. So look, okay to use your calculator on these and just leave your answers like rounded to the nearest tenth maybe. 3,000 divided by the square root of 51 is 420.08 or 0.1, whatever, miles per hour. We'll check my little answer there, make sure we're doing okay on that one. I guess I could look at that, 420.08, we're all good. And we're going to move on to problem 14. 14 is flying a kite. Inga flies a kite at a height of 300 feet. The wind carrying the kite horizontally away at a rate of 25 feet. How much let out the string when the kite is 500 feet? Same problem, basically, right? So here we go. She's flying a kite at a height of 300 feet. The wind is carrying the kite horizontally, just like that, at a rate of 25 feet per second. And then the question is, how fast must she let out the string? So that's going to be that length right there. So let's call this, we'll just use the same variables, I guess, s and f. So how fast, the question is, how fast must she let out her string? So we're trying to find ds dt. Where'd it go? When the kite is 500 feet away. When s is 500. All right, so same basic problem, right? We're going to go 300 squared plus x squared equals s squared. The derivative of 300 squared is a constant, so it's 0. 2x dx dt equals 2s ds dt. Got to find that x. So here we go again, same right triangle idea, 300, 500. This one's a little bit easier. That's 400, Pythagorean theorem. I'm going to cancel out the 2, so we're going to go 400 times dx dt, which is 25. That's how fast that kite was traveling, equals my s, which is 500 times ds dt. Do a little algebra. ds dt equals 400 times 25 divided by 500, and I get 20. So I guess 20 feet per second. And we'll check that answer, and we'll be done with 14. 14 is 20, look at that. And back for the last ones, 21 and 31 in just a second.